So welcome everybody. I guess you came to the session because we are going to talk about code. So do I assume you are mostly developers here? Yep. Hands up. Yeah, full room. Nice. So yeah, indeed, I'm going to talk mostly about Kotlin and how to apply it for build engineering in context of TeamCity, because that's currently the only server that supports it. Maybe there are some others that try to leverage Kotlin DSL. Gradle is one example, but that's a build tool, not a CI server. And we're actually going to spend more time coding than looking at the pictures. And this is why I'm trying to invite you closer, because the screen is not too big and it will be easier to see from the front. My name is Anton. I work for JetBrains as a developer advocate for TeamCity. Well, surprise, surprise. And yeah, I have a engineering background from Java, about 15 to 20 years, I didn't know exactly. Yeah, I recently joined JetBrains about a couple of years ago and started to do more Kotlin. And after Java, it actually feels quite natural. So there is no big learning curve if you are coming with Java background or C# background and so on. So it's a general purpose programming language. Incorporates all kind of modern features into it, doesn't really invent the wheel, just borrows the good stuff from the others. So I guess a lot of you are familiar with the notion of configuration as code or infrastructure as code, right? And in many cases, if you start thinking of it, it's not actually as code, but as text. Because what kind of formats do you have to configure in most cases? This is the k-value pairs, the simplest one, the properties files, right? Then you start facing the problems with hierarchies where you have nested properties and you don't want to write those conventions in the properties files. You either take XML, it's not that sexy anymore, take JSON, and well, obviously it leads you to YAML files. And well, you probably all know what it can lead to. I'm not going to spend too much on bringing the examples of good and bad configuration files with YAML. This one is from Azure DevOps Continuous Integration Server. It looks pretty nice, clean. It declares the intent, basically. But you see there is a model, right? There's a domain model behind this configuration file. And as the domain model actually grows, you add more features, more abilities to the tool you are trying to configure with this one. It starts getting bigger, obviously, and there are some constructs in YAML file that make it, easier or more convenient to handle the complexity. But even here, you can see already some behavioral description, not just declare the properties or declare some arguments or objects, but you can see some behavior in the script block already, or at the top there is kind of an include operator as well. Or it's getting bigger and bigger, and it grows in complexity. So there are all kind of funny stories about YAML configurations. We are not going to talk about those individually, but if you want to look up what kind of interesting effects you can get with, for instance, abbreviating Norway to NO, and the parser would evaluate it to a Boolean instead of a string, then there are all kind of funny stories you can read up later. Just easy to remember, no YAML. So the biggest problem with configurations as text, not YAML in particular, is that we are working with some kind of a domain model that we're trying to configure. And as it grows, it starts either become too complicated or starts leaking. The leaking abstraction is another thing that we face with the configurations, because we want sometimes to go around the limitations of the domain model and apply some kind of imperative logic to generate something, have conditionals, and so on. And well, if by any chance the creators of the tool who uses the textual format for configuration have thought through the extension points, then it becomes messy. Then you start creating your own extension points to program things in the textual format. So instead, we could apply some of the developments in the industry that are called programming languages. We are not the only one who are using the programming language to configure stuff. For instance, if you have used Jenkins, you have used Jenkins file, and well, that's groovy. And if you try some other tools like Atomist, for instance, they are using TypeScript. So it's not something unique to the tools like TeamCity, for instance, to configure stuff with a programming language. I'm going to spend a little time explaining what Kotlin is in case someone of you don't know about it. Just a quick show of hands who have tried it. Just a few. It's not too many people know about it. But, well, there is a website called play.kotlinlang.org. I don't know if it renders correctly, where you can just, without installing the compiler and the tooling to yourself, you can try it in browser. And if you're coming from Java background, it will be pretty easy. There are a lot of examples. There are some hands-on exercises to, for you to master the language and get familiar with it. But we are going to spend some time looking at the syntax examples so that we know what we are doing when we are creating the build configurations in TeamCity. So just a few screenshots from there. So it has higher order functions. You don't need to program anything in classes, but it's implied because it's a JVM language. It will be later translated to classes. And you have all kind of interesting things beyond Java, features like extension functions, for instance, when you can add a new behavior to the existing model. And we are going to look into those features right now. So if I open my IDE here, and let me open a file. So how does it look like? Obviously we can create a main function, right? Currently I'm not creating a configuration script. I just want to show you a few things from Kotlin itself. How does it look like? So there are classes, of course, a little bit easier to write than in Java. So just to declare a class, I don't need to create, for instance, how do we do it? Example. So that's the declaration. I have a class, right? I don't need curly braces always for this. Obviously, if I want to enclose functions for this class, I'm going to use the braces, add some kind of a function, let's say with one argument of type string. It returns nothing, and it should have a name, of course, foo, whatever, right? So that's the simple declaration. But we can also add new behavior to the classes, as I was mentioning a few slides back, by declaring extensions to the existing model. For instance, this class could have come from a library, from a jar file, right? If you are Java developers, you know what jar file is. And you cannot change it, but you want to add a new behavior, so it would be natural to use this extension in your program afterwards. So I can declare a new function for that class as an extension and say that it should return a string which might be null. So we have nullable annotations, like null annotations. The question mark means that it should be of type string, but it might be null when it returns. So return null. And well, if I remove the annotation from here, it's going to be a compilation error. It should not be null, right? By default, if we declare a type in Kotlin, it's not nullable. Should not be null. So the compiler is going to immediately check and tell us that we are doing something wrong. Okay. But if we are going to take a look into the scripts that we are going to further use for the configurations, then the often look something like this. For instance, we have some kind of an entry point to our definition pipeline. Talking in the context of build engineering and pipelines and builds and this kind of stuff. So we are going to use those terms here. So, and often it's a pipeline with a block where we define some other things, like there's a build where with the name A with some actions inside, and there will be a block B with some other actions inside. And those verbs here are actually functions, right? That we are going to create to model our domain. In this case, we can create a function called, I probably should, just a second, so that it will be visible from the back row, pipeline. So we need a function pipeline, but it should take a block of code as a parameter. And since functions are a kind of first-class citizens in Kotlin, and also lambdas as well, we can define a parameter as a functional type. This kind of syntax means that it's a function. The block is a function that takes no arguments, empty parentheses, and returns nothing. That's a unit, or a void, if you're more familiar with this terminology. And then we can just call this block internally and execute whatever was inside, right? So we would execute the build from here. If we start modeling our pipeline here, we need to make sure that build is not just a function from any context. We want to make sure that the build function works in the context of the pipeline, so only inside that block. For that, we need to make sure that the block executes within the context of the specific class. So we can create a new class called class pipeline and tell that this block should be executed, or its definition even should be within the context of the class pipeline. And remember about the extensions. So when I was able to add a new function into the existing class, in the same way we can declare that this block can be this block is kind of part of or extension of pipeline class. So now we can just apply this block within the context of pipeline, and here we may say that we want a new method called build. It's not a class, sorry, it's a function. Build, which has a block or a parameter. First of all, there is a parameter which should be obligatory, mandatory. For instance, your block should always have the ID. That goes kind of hand in hand with the API design, where you decide which parameters should be mandatory and should not be mandatory. Because if, for instance, we say that the build should have an ID, and it's always defined as an attribute within the block, this is something you want to kind of your user, like, enforce your user to do. If you leave it optional like this, defining it within the block, the user might forget it and make a mistake, for instance, right? But if we define it as a mandatory parameter for the function, then he cannot miss it. So for instance, we have an ID, which will be a string, and a block of code, which again does nothing, but I need a name for that. Block, right? And it's going to be some sort of function. So you see now it's the build that takes some kind of an ID, which is mandatory, and even with some syntax sugar, we can specify it like this, because it has a notion of named arguments. And then if we are modeling the build, for instance, we could have a class called build, and say that this block of code should be executed within the context of build class, then the IDE tells me, it kind of assists me with the hint that whatever you write within the build here is happening within the context of the build class, so I'm going to have a direct access to whatever members, let's say name, string, then I have an access to that field, right? I can then override it if it was a var, actually. Var. Good. So now you get a feel what Kotlin looks like, right? I hope it kind of opens up some information for you what the language is, and obviously I can learn afterwards more, or come to my booth and we can talk later about Kotlin 2. But let's take a look at something else. Okay, TeamCity. So TeamCity uses Kotlin to configure build configurations. And have you seen TeamCity? Okay, some of you have seen it. So let's take a look how you can configure TeamCity builds with Kotlin DSL. Here I have a project which is currently empty, and we are going to populate it with configurations. To make it configurable through the Kotlin DSL, through the code, I have to enable versioning for that project, version settings, enable the synchronization, select the repository where the settings will be stored. It can be the same repository as the repository for the project that you're trying to build, or it can be also like a dedicated repository, because in many cases, people are trying to build pipelines from multiple repositories, and it's then wise to just have a dedicated repository for the settings only. Then I can select the format. Currently it's Kotlin. It could be XML as well, but XML is not really human editable in TeamCity. There are a lot of technical attributes to fill in which you don't know how to fill. And with Kotlin, they are just removed. It's generated. And then at the bottom, we can see the status, what happened. When we enable it for the first time, the TeamCity will actually generate the settings, whatever the project is. If there are some objects already like build configurations, VCS routes, properties, it will just scan them, generate the Kotlin configuration file, and commit it. And here's the result of the commit. In the repository, it's actually so .teamcity, probably too big. Okay, so it's going to be a .teamcity directory where you have two files by default. That's pom.xml, which describes all the required dependencies, because it's a statically typed language. It kind of compiles against the dependencies. It needs runtime libraries and so on. And there is a settings KTS file, which is currently, well, basically empty. There is just one attribute that indicates the version of TeamCity or the version of the DSL we are going to use, depending on the version of TeamCity. And there is just an empty block called project. And this is where we start creating our configurations. So now I can just pull in this project into my IDE and start editing. So let's see, what can I do? So here's the settings.kts, which is empty. There are some comments, and I probably don't need them. I just remove this block from here. Is it visible? Everything's good? Nice. So what we need to do to build something in TeamCity is to create a build type. If you have used TeamCity from the UI, normally you are used to the term called build configuration. This is basically the same thing, but in DSL you are going to use build type everywhere. So build type, and it receives either either a block of code or a type definition. Like there are two overloaded methods. We are going to look at both of them and see the difference. But if we want to create a build configuration, what we need to do at first, we are going to use a conventional, let's say, version of the DSL, which you will see if you generate everything from, like you configure everything in the UI and you generate the settings, and this is what you are going to see. So the build type is going to be an object. Let's say we are going to call it a library. And here we are going to specify all kind of things like triggers, build steps, VCS routes which are connected to this build configuration, artifacts. So, and when we are using it for the first time, we obviously need some kind of an assistance from the IDE. VCS route, we don't have the VCS route yet, but we are going to define it later. We maybe want some kind of an artifact rule. It's going to be a Maven project, so it's going to locate in targets somewhere. It's a jar. Then we need to, let's say, declare a steps block. Inside the steps block, we have some kind of built-in actions like for Maven, for instance, Maven, and goals, clean package, and then a triggers block, let's say a VCS trigger. So we are going to react. What is happening? Okay. I switched to a different project. Okay. So there is a VCS trigger as well. So it's like a basic build configuration, and we need to register it under the project library, and we need a VCS route. So we are going to define that one as well. Let's see, I'm going to create a VCS route, call it a library VCS. Yep. So a URL, a name, branch spec, which branches we are going to monitor for the changes, and so on. And we need to specify that as well here, and need to say that this VCS route is also, part of this project. Library VCS. So that's a basic configuration. Let's switch off the triggers for now because we don't want to trigger that immediately. Like this. And once I make a commit, say we are adding a new config and make a push. So we added a new configuration right here, so we have it in the repository. And if you go back to TeamCity, TeamCity detects the changes itself immediately and regenerates the, as you can see, my commit here, adding new config. So it tells me that I have created now a new model, a new project model in TeamCity from those settings from this revision. So one thing to notice is that it did it immediately without me asking for it, right? So it means that the generated model is going to be used during the build, and during the build, TeamCity is not going to execute that configuration file anymore. So it's static, right? We use Kotlin here to generate the settings, not to execute the build. And the primary benefit here is that it's statically typed, and the tool assistance is there, and we are overcoming those leaky abstractions as well with the programming language if we need to generate something, make conditionals, and so on. Okay, so how does it look now in the interface? We have a configuration called library. This was just added with some of the settings. Like we have a build step, right? pom.xml, clean package. So everything is there. But you can still edit it through the UI. And if you do that, well, there is like a question now. We have something defined in the programming language which might, have its own constructs, its own classes. You can create new classes, you can create new functions, and TeamCity doesn't know anything about that because it only has a model. So if you do change something in the UI, it will actually generate a semantic patch and commit it to the repository, and then it's your responsibility to merge that patch back into your application, into your Kotlin script that configures everything. Right, and we have a version control here, library, VCS, and so on. Good. Any questions yet? No? Okay, so what if we need to create a very small pipeline? Let's say we're creating a library first, we are building the library, and then we are using this library somewhere in the application as a dependency. Right, then we need another build type called application, for instance. Application. And we are going to need a VCS root called application VCS, for instance. And it's going to reside in the application repository. And say we want to build it from this VCS root. VCS root application, VCS, and we need to build it as well as a Maven project, for instance. Calls clean package. And we need to specify a dependency as well. So there are dependencies block. And in TeamCity, we have a notion of snapshot dependencies and artifact dependencies. So here we have, for instance, a snapshot dependency. I'm going to explain what it is. A snapshot dependency on the library. And we may assign different properties to that dependencies as well. So for instance, if the library is producing some sort of a large artifact and we don't want to transfer it through the network, we may declare that this new application build should be running on the same agent. So run on the same agent, true, right? So TeamCity is going to make sure that the artifact stays there, it's cached, you don't have to transfer it, and the dependency is not transferred over the network. Or if we want to have a dependency declare that we need an artifact from the previous build, we declare that it's going to be an artifact dependency from library, and we need to specify the artifact rules like this. Target some file, right? Let's remove that for now. So we have a basic configuration right now, and it's going to be easy to check if we register those configurations and those new VCS roots under the project as well. Application VCS, build type, application VCS, and so on. Sorry, what's going on? Okay. It's not VCS, but you see, if I'm making mistakes, it tells me immediately. So application config, go, push. So it's going to kind of pull the repository and pull in the new version of the settings. So it's generating the new project node again. Gonna have to wait a little bit. Okay, application config is there. We have another application under our project. If we execute this new configuration, for instance, since it has a dependency on the library, it is going to execute the library first and then the application. Let's see if it works. Maybe I misconfigured something. Hopefully it works. So it's running. It's going to pull in the source code, execute the Maven task, do all kind of checks that it needs to do by default, and we need to get a final result like a green build afterwards. What I want to see now after this run is the diagram of the builds. We have two builds separated, but they are dependent. And I want to see a pipeline. Probably I should have just created an empty build steps block, so it would be faster then. Still running. So the build step, okay, Maven downloading internets. Okay, so we're going to wait a little bit. Anyways, while it's running, let's see what else we can do here. If we have a chain of builds, let's say, like in this case, we have a library, we have an application, we might have some tests after that for the application, packaging, deployment, and so on. So we have kind of a graph, because some of the stages in the graph might happen concurrently. It will be interesting to see how we can trigger the build, when this pipeline should trigger the build. So if we start thinking of pipelines as a sequential process, like first step completes, the other step should start after the first one completes, and so on, then we start defining the triggers in every stage. Like, please start the build on the change, and then please start the next build triggers. Finished build trigger when the previous one completes, and so on. So it leads to kind of a triggering bloat. So as many configurations as you will have as many triggers at every stage. And this is like bad in two ways, because first of all, it's the maintenance cost for you as a person who configures the scripts, because once you need to change something, you have to go in every build configuration and start changing it. And it's also an overhead for the server, because it has to maintain every trigger and has to poll, or whatever the trigger definition is, has to poll the database, it has to check the timer. So it's a performance overhead as well. Instead, what we can do is to set the trigger only in one place at the end of the chain. So in our case, it's the application build type, and say that it's going to monitor for the changes in the Git repositories, but it also should monitor for the changes in the dependencies. So watch changes in dependencies, true. So this is what we need. If there is a change in any of the snapshot dependencies, this is like a powerful concept in TeamCity, snapshot dependencies, that forms the build chain. Let's see if our build completed. Okay, compilation error. But we are going to see the build chain. So you see it here, right? So this arrow between the two, 10, 5, 10, perfect. So this arrow between the two is the snapshot dependency, and the Boolean flag that I'm specifying here is the one that tells this build chain to monitor whatever changes there are downstream or upstream. Okay, what I wanted to show you today with JFrog CLI is actually how I wanted to use JFrog CLI as an example when you need something really custom and you want to add it into your DSL in Kotlin, how Kotlin can help. We don't have a specific build step for JFrog CLI. There is no plugin for it. There is an Artifactory plugin if you want to integrate TeamCity with Artifactory. But it integrates directly with the build steps that we already have. But if we don't have a plugin, or if you don't have a specific integration with the specific technology that you can execute from the command line, then actually you can use a script build step, script content, and just run whatever you like from here, right? But that's not really convenient in a way that it's not type checked, it's not, you don't get any assistance how to write this command, and so on. So you end up writing something like, I have another example just to save some time for you. This is a build definition. And are you familiar with JFrog CLI? That's basically a utility that uses a RESTful API to upload the artifacts and so on. So I'm not going to spend time explaining what it is. So in here I have a script content block that I was just about to write that uploads an artifact to some generic repository in my Artifactory instance, and it provides some of the arguments that I need, like a build number, build step, or build name, URL of Artifactory, username, the password, right? And the password is scrambled right now. So we say that we cannot store them in plain text, right? We provide a password as a parameter, and the real password is stored somewhere in the security store. It might be Vault if you're using Vault, for instance, and then TeamCity has integration with Vault and going to pull in the password from Vault instead. But this string here is a reference, or kind of a key to that storage where the password really is in a scrambled format or whatever encrypted format there is. And then what I need to do when I was showing you what Kotlin can do, right, to add a build step that would be statically checked, I add an extension function to this block that is called build steps in TeamCity. And that function is going to be, is going to work only in that context. I call it JFrog, and then I define my own domain class called JFrog CLI, where I specify all the commands, all the fields, like options for that utility, and then it's kind of abstracted or gated. The string that should execute, the command line string that it should execute, is kind of hidden from the user, and instead what user sees is this, right? So I have a new build step suddenly. I don't have it defined anywhere. In libraries, TeamCity doesn't provide that. I only have it in my own configuration script. And then if I'm using, let's say, JFrog, and I want to start typing something here, it immediately tells me what are the attributes I should define in that block. And even more, if I, let's say, define this build script as not defined, but I annotate with a specific annotation provided by, there is a specific annotation in Kotlin that you can derive from, and then annotate your own DSLs with that new annotation, TeamCity DSL, TeamCity. So I need to annotate those members, the individual members in my DSL. Let's see. And if I go back to the script, suddenly they are highlighted with a different color. And if I ask the completion from the IDE, those DSL members that I declared as DSL members, they are going to be on the top. So tooling starts helping here that, hey, this is a general purpose programming language, but suddenly it helps me specifically in my domain, in my like general domain for build engineering, and specifically in my use case here for adding a new command, to my DSL, whatever it is. So I guess we are almost running out of time, and I don't want to stand between you and the lunch. So if you have any questions right now, I'm happy to answer. If you have any questions later, we are at the booth, the JetBrains booth in the expo. So come to me and we can talk. Nope? Well, maybe later. Thank you very much for coming.